Okay, so the question was asked, why do we ignore the remainder when finding oblique asymptotes? So here's an example of a rational function where the degree at the top is greater than the degree at the bottom. 2 is greater than 1. So we know that there is no horizontal asymptote for this, and we would have to go and find what we call an oblique asymptote or a slant asymptote. In this case, I can do it by synthetic division because it's a linear divisor. So 2, 1, 2, negative 1. Bring down, we got 1, 2, 4. 2 and 4 is 8. We get 7. So my result from dividing x minus 2 into x squared plus 2x minus 1 results in y equals x plus 4 plus 7 over the divisor x minus 2. Alright, so let's reanalyze what's going on here. This f of x up here is actually identical to this y down here. All I did was divided the top by the bottom and rewrote it. This is no different than saying that 8 divided by 4 equals 2. So if my goal when given a rational expression is to find the end behavior, what's happening at the ends, let's now look at y, our new y, and figure out its end behavior. Well, how would we do that? Well, let's think of it as 3 separate rational expressions. So let's think of x, 4, and 7 over x minus 2 as rational expressions. X would be y equals, it would be, let's write it as x over 1. Let's go 4 as 4 over 1. And then we already have the last term as a rational expression, 7 over x minus 2. So if you could see what I did, I tried to rewrite each as a rational expression. So let's look at the first term. This term is x over 1, so the degree is 1 here. The degree of the bottom, when it's a constant, is 0. So this means that this one would be going off to infinity. And if I think about it, if I'm looking at end behavior, I'm looking as x goes to positive or negative infinity, x would go to infinity. If I look at my next term, I have degree of the bottom over degree of the top. And I'm sorry, degree of the top over the degree of the bottom, and what I have is the same degree. Therefore, I would do the ratio of the top to the bottom, which is 4. So as of right now, as I go off to infinity, I can just plug in x, and I get x. I have 4. But what about the last piece, the remainder? Why do we ignore the remainder when trying to find a slant asymptote? Well, let's think about it. If I'm going to positive or negative infinity, the degree of the top is 0, the degree of the bottom is 1. And when the degree of the top is less than the bottom, this will go to 0 as a horizontal asymptote, meaning this whole function is going to 0. That is why we ignore the remainder when looking at a slant asymptote. If you have any questions, bring it to class. See you on Wednesday.